When you are solving a system of linear equation with three variables by means of a Cramer's rule and by inverse method will not give you the solution for all type of problem. If you look at the Cramer's rule and inverse method, when your determinant of A gets 0, the method fails. Those methods can be calculated only for the problem having, or only the system is having the determinant value something other than 0. When it gets 0, then the method fails. So we need some supportive method. The very effective method for all type of problem is the rank method that you are going to discuss now, right? If you look at the system of equation, there are three types of solution that we can find. The first one is a unique solution. Can you see the first diagram A? So if you look at this three plane, so each plane represents an equation. This is a system of three variable with the three equations, and if you see all the three planes meet at one point. Can you see this common point? That we call it as a solution for the given system. The intersecting of the three plane, that point is the solution. So this one point represents there is a unique solution. That means for the given system, x has a unique value. Unique value means only one value for x, one value for y, and one value for z. If you look at the second case, the three planes are intersecting at more than one point. That is why it is represented as a straight line. Is it okay? That means on this line, you can take any point that will be represented as a solution. Is it okay? So the second case of the solution is infinitely many solutions. That means the x, y, z has more than one point. Is it okay? One value. Now if you look at the third case, there is no intersection between the planes. When there is no intersection, it means the system does not have a solution. If you look at the previous two methods, whether in Cramer's rule or by means of inverse method, we have not discussed in detail about the types of solutions. Is it okay? Whereas in the rank method, first we will discuss how the solution will be. After then, we will find out what is the solution. Is it okay? So first step, we will discuss what is the nature of the solution, whether it is a single unique solution or it has a infinitely many solution or it has a no solution. First we will discuss. After the discussion, then we will find out if there is a solution, how it will be. All right? So let me solve. And step 1. Solve the following system of equations. Given a system with a three equations with the three variables. Okay? Using rank method. Is it okay? Step 1. Step 1 is common to all the three methods. What is step 1? We write the given equation in a matrix form. What is the matrix form of writing an equation? Ax is equal to b. So what is A? The coefficient matrix of the variables. So from the first equation, what is the coefficient of x, y, z? 2, 4, 6. The second equation, 3, 8, 5. The third equation, minus 1, 1, 2. Multiplied with x, the unknown. X, y, z. This is what we need to find. And that is equal to b. What is your b? 22, 27, 2. So this is your step 1. Now step 2, I'm going to construct a matrix named argument matrix with A and B. if it is a ranked method, you are going to construct a matrix. The name of the matrix is an argument matrix. How we construct? We combine that A with B. What is the matrix? This is your matrix A, and this is the matrix X, and this is the matrix B. Now I take the matrix A. What is the matrix A? 2, 4, 6, 3, 8, 5, minus 1, 1, 2. I combine with the matrix B. What is the matrix B? 22, 27, 2. So this matrix, we call it as an argument matrix A with B. Clear? Now, after you construct an argument matrix, we are going to apply a row echelon method. We are going to apply the row echelon method so that we reduce this matrix to a simplified form to get the result. Is it okay? I'm going to reduce this matrix using that method called as row echelon method. Is it okay? What is row echelon method? So I will try to make it first as an upper triangular matrix, and then I will try to reduce as much as possible if there is a chance. Is it okay? Now, so according to the row echelon method, first step, we change the first column elements as 1, 1, 1. You can use operations like addition, subtraction, multiplication, or division. So anything that can be performed, but it should be uniform. You cannot do addition or subtraction to a specific element in a matrix. If you are performing an addition, it should be common to all the elements in the row or common to column. We are performing a row echelon method. That means we are using the row reduction method. Is it okay? So we consider the rows. Now, see, if I want to make the element 2 as 1, what I am going to do is I am going to divide this row 1 by 2. This is equivalent to. What I am going to do, I need this 2 to be 1. So what is the reduction method? What is the reduction I am going to use? I divide this row 1. I consider this as row 1, row 2, row 3. I am going to divide row 1 by 2. So if you divide by 2, what do you get? 1, 2, 3, 11. So I need to explain what happened in the row 1. Row 1 is replaced by R1 by 2. So this explanation will clearly gives the examiner that the step is taken by dividing 2. Now, I need to make this 3 as 1. What is the reduction I'm going? What is the operator I'm going to do it here? Division. So here I divide by 3. 1, 8 over 3, 5 over 3, 27 over 3 will be 9. I need to explain that R2 is divided by 3. Now, in the third row, you have a minus 1. So what I have to do? I divide by minus 1. So this will become 1, minus 1, minus 2, minus 2. So R3, I divided by minus 1, or you multiply by minus 1. Anything is fine. Any questions? The next step, keep the first row as it is. Keep the first row as it is. No change in the first row. Till the end of the problem, we are not going to disturb the first row. It will be same as what we get in the second step. So 1, 2, 3, 11. Is that okay? Now I am going to change this 1 second row first element, this 1 as 0, and the third row first element, the 1 as 0. Is it okay? To change this, I'm going to give the operation. I'm going to change the row 2. How I am going to change the row 2? The operation is with row 1. So R1 minus R2. I am going to subtract R2 from R1. You can do it like this, or you can do R2 minus R1. Anything is fine. Either you do R1 minus R2 or you do R2 minus R1. It's okay. Right? Now I am going to perform R1 minus R2 operations. This is R1, right? This is R2. 1 minus 1, 0. 2 minus 8 over 3. Minus 2 over 3. 3 minus 5 over 3. 4 over 3. 11 minus 9 will give you 2. Any questions? Now the R2 is done. Now in R3, same. R3, I am going to perform the operation R1 minus R3. Now with R1 with R3. Right? So what do you get now? 1 minus 1, 0. 2 minus of minus 1, 3. 3 minus of minus 2, 5. 11 minus of minus 2, 13. Are you clear with the step 3? Is that okay? So now we made this 0, 0. The row echelon method. So now in the second column, I'm going to make, I told you the first row is same, no change. Is it okay? Till the end of the problem, no change in first row. Now in the second row, I'm going to make this element as 1 and this element as 1. Same like in the first step. So if I want to, I'll write down the first row. If I want to make this minus 2 over 3 as 1, what I have to do now? What we did here, if I want to make the 3 as 1, we divided by 3, is it right? Now I want to make this minus 2 over 3 as 1. So I need to divide by minus 2 over 3. You got it? So now R2, I am replacing this R2 as R2 over minus 2 over 3. So what we get now? 0 by anything is 0. Is that fine? Minus 2 over 3 over minus 2 over 3 will give you 1. 4 over 3 over minus 2 over 3. If you know the simplification, do it manually or use the calculator. Is it okay? So this 3 will be cancelled and you will get minus 2. 2 over minus 2 over 3. So this 2 will be cancelled and I take this 3 to the numerator, it will be minus 3. So this is the new row of R2. Any questions? Now R3. What I have to do in R3? R3 divided by 3. So what we get now? 0, 1, 5 over 3, 13 over 3. Is that okay? Now we got this 1, 1. Now I am going to make the third row, second element 0. First we make this 1, 1, 1. Then I made 0, 0. In the second column I made this 1, 1. Now I am going to make the third row, second element 0. So for this is equivalent to, I told you there is no change in the first row. 1, 2, 3, 11. Is that okay? Now the second row is same. No change in the second row. 0, 1, minus 2, minus 3. I am going to change the third row. How I am going to change the third row? At the beginning we did the operation with R1. Now if I do operation with R1, there is no use because we will get some value here. So now I do operation with R2. R2 minus R3 or R3 minus R2. It's up to you. So now this is R2, this is R3. 0 minus 0, 0. 1 minus 1, 0. Minus 2 minus 5 over 3 will give you minus 11 over 3. Is that okay? Right? Minus 3 minus 13 over 3 will be minus 22 over 3. Any questions? Is that clear? Now we got the upper triangular matrix. If you see here, upper triangular matrix means below the leading diagonals, all the elements will be 0. If you remember the first lecture, we discussed about the type of matrix. What do you mean by an upper triangular matrix? Below the leading diagonal, if all the elements are 0, that is an upper triangular. Is it okay? Now we made an upper triangular matrix. Now we need to think. Is this is the final reduced matrix or still we can able to reduce? Is it okay? You have to reduce as much as possible. So to know this further reduction, first we make the matrix as an upper triangular. Then we will check is this is the final reduction or further can be reduced, right? Now, how to verify that it can be reduced furthermore or not? It's so simple, right? I'll give you some examples to test your skills. There is a matrix like this. Some element, some element, some element, some element here. Is it okay? You have a 0, there is some element, there is some element, there is some element. Is it okay? 0, 0, there is some element and there is some element. Is it okay? This is case 1. I'll give you another case. Same thing. Sometimes you may find this kind of cases when you solve. Is it okay? Look at these 2 cases. I'll give you one more case. How to check whether this is the final step or we can reduce further. I gave you 3 cases, right? See, now I will give you the definition. So far I have not discussed about what do you mean by a rank. Is it okay? So the rank means, the definition for the rank is the number of non-zero rows. What do you mean by rank? The number of non-zero rows. What do you mean by non-zero rows? If I say 0 rows, what do you mean by 0 rows? All the elements in the row are 0. This is 0 row. What do you mean by non-zero row? 0, 0, 0. At least one element will be present in the row. That is called as a non-zero row. Like that, how many non-zero rows that you have in a matrix, that we call it as a rank. Is that clear? Now, to find the rank, we try to reduce as much as possible so that we confirm this matrix has this many non-zero rows and that is the rank. Is that okay? So now, if you look at here, 0, 0, 0 an element. So that means this is the final step. We cannot reduce furthermore. Do you understand? 0, 0, 0 an element. And if you have an element with element, element with element, that means this is the final step. You cannot reduce further. Now look at here. 0, 0, 0, 0, element, element. That means I can try to make this element 0. Same like I need to make 1 and 1. Then I subtract to make this element 0. Is it okay? So we can think about further reduction. Look at here. 0, 0, 0, 0, 0 element. So that means this is the final step. We cannot go with, tell me, we can go further or we can stop. 1, 2, 3, 4. 0, 4, 5, 3. 0, 0, 1, 2. Can we stop or can we continue? Very good. If I give you 0 here, continue to make this 0. Is it okay? Is that clear? Now if I give you 0 here, stop. If I give you 0 here, continue to make this 0. Is it okay? Now if there is 0 here, stop. Is it okay? Now what is the rank? Rank of this matrix is the first row everything is 0? No. Is the second row everything is 0? No. Third row everything is 0? How many non-zero rows you have? 2. This is rank. Do you understand the meaning of rank now? I'll give you another example. 1, 2, 3, 0, 1, 3, 0, 0, 4. What is the rank of this matrix? Is it all 0? No. Is it all 0? No. Is it all 0? So that means rank will be how many non-zero rows? That is called as a rank. Is it clear? Now we will move back to our problem. Now 0, 0. 0 element. Element. Can I continue or can I stop? Clear now? So now I stop here and then I will write rank of A, B, and then rank of A, and then number of unknowns. I will write the 3 things. Once you stop the row reduction method, immediately you need to write the rank of AB, rank of A, rank number of unknowns. What do you mean by number of unknowns? What do you want to find from this system? X, Y, Z. So how many unknowns you are going to find? 3. Clear? AB. See, this is, if you look at here, 1, 2, 3. This is your A and this is your B. Am I right? So this is a combined matrix, argument matrix A with B. Now for the A, B together, let us see what is the rank. Is it all 0? Is it all 0? Is it all 0? So then what is the rank of AB? Is that clear to everyone? Now we need to check the rank of A. When we check the rank of A, we take only this A. Only the A. Is that okay? Is that clear? So now check the rank for A, only A. Is it all 0? Is it all 0? Is it all 0? So then what is the rank of A? 3. Do you understand? Now with this rank, we are going to write down the nature for this given equation. How to write out the nature? If your rank of AB and rank of A, if they are equal, rank of AB, the rank of A, if both are equal, what it says, there is a solution. If they are not equal, then you can write there is no solution for the given system. Do you understand? So two things are there from the rank. Rank of AB and rank of A. If both are equal, there is a solution. If both are not equal, no solution. Is that clear? If you say that there is no solution, stop here, finish. There is no solution, why we need to continue? If there is a solution, we need to continue and tell what is the solution. Do you understand? Now, are they equal or different? Then means there is a solution. Yes. What do you mean by that? I will discuss with you. What is it? Number of unknowns. Number of unknown means what do you want to find? X, Y, Z. So 3 unknowns. That is why I wrote here 3. Is that clear? Now, if you have a 4 variable, then 4 unknowns. 5 variable, 5 unknowns. Am I clear? See, we don't write it. Actual meaning is there is a solution. Technically, we write it in this way. The given system is consistent. Is it okay? If I say consistent, means there is a solution. If I say inconsistent, no solution. Do you understand? So hereafter you need to use the mathematical terms. If I say consistent, that means the system is having a solution. If I say inconsistent, the system does not have a solution, no solution. Clear? Now, okay, we said there is a solution. If there is a solution, first we discuss two types of solutions are there. Unique solution, infinitely many solution. Do you remember? Now we need to say, we said there is a solution for the system. Either it is a unique or infinite. We need to check. How to check it? And has. Now, how many solutions are there? Now come back to this third one. What is it? Number of unknowns. The rank of AB, rank of A are equal, and it is equal to the number of unknown. Is it okay? When all are equal, it means it has a unique solution. Do you understand? If the rank is less than the number of unknown, that means many solution. If the rank is less than the number of unknown, many solution. But here, same. So what is the solution here? Unique solution. What does it meaning of a unique solution? There is a one value for x, one value for y, one value for z. So far is it clear? Right? Now we need to know what is the value. To know the value, we are going to use the method called back substitution method. What is the method we are going to use? Back substitution. It's so easy. I will copy this matrix. The last step. I'll take the last step. This is the last reduced matrix. Is it okay? That is why we try to reduce as much as possible. All right? So now, this is the final reduced matrix. Listen carefully. We are going to use the method called back substitution. This is x, y, z, and this is your b. Is that okay? Back substitution method means from the last row, I take the last row. From the last row, I will find a variable. From the second row, I will find the second variable. From the first row, I will find the third variable. That is why we say the back substitution. From the last row to the first row, we will go one by one. Look at the last row. What do you have the first element? 0 times of x. X is 0. What is the second element? 0 times of y. What is the third element? Minus 11 by 3 times of z equals, what is the right hand side? 22 by 3. Are you okay with this? 0 by anything is 0, 0. Can I find z here? What do you mean by z here? Z is equal to minus 22 by 3 over minus 11 over 3. Are you okay with this? So if you cancel this, you will get the result as 2. What is your z value? Finish. Now you got the first variable. Is that clear? Now I move on to the second row. What is there in the second row? 0 times of x, 1 times of y, minus 2 times of z equals minus 3. So 0 by anything is 0. We need y. You know z. What is z? 2. And you simplify this. Minus 3 plus 4. What do you get? 1. So we got our we got our y, z. What is remaining? So let us move on to the first row. 1 time of x, 2 times of y, 3 times of z equals 11. So x, we know y, we know z, and this is equal to 11. So x equals 11. 6 plus 2 is 8. On the other side will be minus 8. And what is your x? 3. So we got our x value, y value, z value. And what is the matrix, unknown matrix? 3, 1, 2. This is what we need to find. Is that clear? So in the previous two method, we have not discussed about the nature of the solution. But the rank method, you will understand what is the given system and how the solution will be for the given system.